Yeah, I think we're good. Okay. Yeah, so we basically have a bunch of containers, which need to be configured. So these containers are running, let's say, either at a cloud provider or at some local, like small cluster, or even on the same machine if it's powerful enough. So the components which are held in these containers can be classified into like some categories which fall like a compute element or a batch system or a worker node or a squid proxy. So we don't have to worry about the squid part this time. So there are two levels of configuration which take place. So the first level is like a central configuration module, which I described in the slides I shared on the Google group. So the task of a central configuration module is to make sure that on all of these nodes, which might be distributed uh, to some aspect in a local network, all of these nodes are connected either via Puppet or Ansible, so that if you tell Puppet to like start a container on that particular node, you're able to do it. If you want to run like an Ansible playbook on a particular node, you can do it from like one central node. So that's like the level one of configuration, which is kind of like a master interface to all these containers. The second level, if you have any questions, just stop me anytime and feel free to ask. Okay. The second level of configuration is basically configuring, like running a Puppet or a Ansible client inside these containers, and then using some information and external parameters in configuration files, so that when the container boots up, it can start like a Puppet module or Ansible playbook that gets this data from outside the container and configures the container to run in that environment. Make sense? Okay. So now if I talk a little bit about more, let's say, details of these configurations. So for this second level configuration, so what exists today, what exists like before I started working on the project was something called a YAME based configuration. So YAME is basically a funny name, which I think is like yet another infrastructure manager. So it YAIM. So it was built by the people who were working at CERN on the WLCG, because at that time there was no Puppet Ansible share for any like good configuration engine in the market. So it's basically a tool which has like several shell scripts, which and this tool basically manages what shell script needs to be executed for the configuration to occur. So because now we are in a time where we have like better options than YAME, like Puppet or Ansible, the idea is to move towards these tools. Okay. So now if I talk about components, uh, like the component that we are primarily concerned with is a cream compute element, a torque batch system, and on the worker node there are some middleware packages which need to be installed, which are just RPMs, and a torque client so that it can receive like workloads from the torque batch system. Okay. Uh, so like at a so like one of the tasks which we'll be doing over the summer is that as a student, so like I'll be working on a parallel implementation in Puppet, which is already ongoing, and you will be working on like a parallel implementation in Ansible. So for like the level 2 configuration. So let's say we need a container which when started and supplied with like a text file with configuration parameters is able to configure itself by running a Ansible playbook inside of it. uh, to like some certain setting, uh, and we have to do it for like a batch system, a computer element, and a worker node. So you might obviously be curious about the details of like what are these configuration parameters, what these packages are that need to be installed in the container, right? Uh, so I'll like share like a more public document on the group, because like I was having word with Martin, and so like a lot of the details in this like project at this stage, they can be like a lot of information for you guys to grasp. So we don't want to like scare away or like uh, you guys, because like honestly speaking, there's not a lot of configuration that we personally have to deal with. So can you see my screen? Okay. So let's say this is our CE, which is a compute element and a batch system inside of it. So you can see like there's a file for like torque and Maui. So Maui is basically a scheduler for this batch system, torque. So torque is based on PBS. PBS is like a very well known and old batch system which was very popular back in the day, and adaptive computing is the company which used PBS and released torque, which is slightly a better version of it. But the batch system for scheduling does not uses like its inbuilt scheduler. It rather relies on Maui for scheduling the jobs. Okay. So right now this folder which you see here is based on Yame. Uh, it is not puppetized, right? So the way it works is like there is uh, like a configuration file, which is this cream info.def. Yeah. So second level is that you have a container. So like in first level, you just still start blah container on blah node, right? In second level, the container should be self-sufficient, so that let's say if in container you have a Puppet client installed, or you just have like a masterless Puppet installed inside the container, okay, and then you have like this def file, like this you supply it with an external configuration file, because containers can like share a volume with like the host and be fed like at least one configuration file. So now inside the container is where this level 2 configuration occurs, which is that given this configuration file from outside the container, our masterless puppet, for example, should be able to configure the container based on parameters specified in this external configuration file. So these parameters, I can like help you take a look at it. Why is my text editor? Okay, it's here. Okay, so for example, like these are approximately like the parameters which we need to specify externally, right? So like MySQL password, the list of worker nodes which is specified in another file, the users which need to be created inside that container, the groups which need to be created, and then there are like information related to the compute element, like what's the batch system, so it's a PBS. Then some like random details like CPU model, speed, vendor, blah blah blah. So then these are like VO specific stuff. VOs are virtual organizations. So basically, like a quick note about what these VOs are, you will definitely hear a lot about them over the time. So once you set up a grid site, right, then what it means is that a scientist anywhere in the world will probably like push some code which needs to be executed on your grid site, right? Yeah, there definitely is documentation, but I'm not very sure how up to date it is. So I did point, like there are some presentations which we attached on like the Google Summer of Code page, which I hope they discuss grid size. I can just take a look. If not, then yeah. And web software foundation. Let's take a look. So basically, what these VOs are like, if now we cannot let any scientist get access to the site. So there are like certain groups or virtual organizations that a site supports. So only like the group of scientists or researchers who belong to a particular virtual organization can access like the resources at a site. So which means like at the site you need to provide information about like what virtual organizations is this site going to support, and like so we have some like VO related configuration which you can see in this like YAML based configuration file. um, yeah, so all in all I guess YAML uses around 100 something parameters for setting up the site. I can set them up. Yeah, so I'll have to like put it in a repository somewhere and give you the link. I can take a note of it, right? But just remember, like at this stage, it does not really matter for you to know exactly what the parameters are. We just know that because like if you don't understand all of these parameters, it's totally fine. Okay, so because to be honest, even I'm not 100% proficient with YAML. It's a very homebrewed system. So ultimately, what YAML does is like it reads these parameters, and then it runs shell scripts in the back with these parameters, and then it basically configures the packages on the operating system, which correspond to Cream in this example because we are looking at the configuration of Cream. Yeah. So if you remember, like I think I shared some link on the forum, which directs you to like configuration of Torque or Cream, um, and like over there, like these parameters are ultimately used to set those values in Cream. So when we'll be implementing this like second level configuration in Ansible, uh, okay. So what I was saying is like these parameters are actually fed to the Cream compute element. So like they correspond to the configuration parameters that we saw on the link that I shared on the Google group, right? And yeah, so when working on the project, we will be skipping this part of YAML and we'll be creating our own like mapping of parameters for Cream. Okay. Yeah, it's definitely online in some documentation as well. So uh, yeah, for example here, uh, so this EMI thing which you see is like the EGI middleware, which is basically so the middleware is a bunch of packages which do a lot of things in the background for the entire grid. So like uh, so there's also like a central EMI repository which hosts Cream and Torque and Maui, for example, from where we can like fetch their RPMs for installing them in the container. Yeah, so you can find a lot of configuration based on game over here. Uh, People 5 install protect this. I think I can. I'll just look it, curate it, and then put it up on the forum for you later to take a look. Yeah, cool. Yeah. So basically, let's stop sharing the screen. Yeah. So we have a so like the tasks for the summer would be to create like containers that are configurable with Ansible on the level 2. The services that we focus on are Cream, the latest release, Torque's latest release would be ideal, but we can also stick with Torque version 4.2.10, I think, which is available in the EPEL repository for CentOS 7. So all of these containers will either use like CentOS 7 or SL7 um, or EL7. So basically, like the packages which we are concerned with should be compatible with this, like with these operating systems. And yeah, so we set these, we create a container with a base of like SL7, EL7, or CC7. We install the appropriate middleware packages. If we are working on the container for compute element, then we install the cream packages from the like EGI repository, and then like we for the level 2 configuration, we assume that we get a configuration file from outside from the level 1 configuration system, and then we basically run like we inside the container we run the playbook to use that file and like do appropriate configurations. So it might at some point also require us to like look deeper into like what EAM is doing with the shell scripts, uh, and like try to replicate it in a clear manner in Ansible or Puppet. And like then we also have to like work on level 1 of the configuration. So in the level 1, so like I'm working on this, so like if you remember the slides, uh, so I described like a central Puppet module over there, um, and that central Puppet module is going to receive like a site level configuration file the from like the site admin. And so the task of this. Okay, yeah, no problems. Yeah, so basically, so we also like will be working in the summer on like a Ansible based central module, which is like the level 1 configuration, which is basically responsible from getting information from the site admin about what infrastructure he has. Secondly, like what compute element or like what repositories he wants to use for configuring that particular infrastructure. So he basically tells, I want a cream compute element, I want 10 worker nodes, and like a batch system which is Torque, and then basically like feeding this information to the configuration validation system, making sure that he actually has the infrastructure that he's claiming to have in that site configuration file. So this is a task of Ansible, of like validating the infrastructure using the configuration validation engine, and then validating the site using like the configuration requirements of the repositories. And then like in the final stage, the Ansible, like the central Ansible module or Puppet module is going to configure our hardware, like the infrastructure with the mentioned repositories, uh, and like provide the information needed by the second level configuration, uh, like containers. The level 2 configuration required by the containers. The level 1 has to make sure that that information is available to the containers. Make sense? Most of it? Yeah, sure. Like, tell me what does not make sense, because I might not be very clear in explaining, and it's not very trivial to understand. It took me quite some time to like get used to this ecosystem myself. So uh, I think it's actually up to you. There's no like hard requirement from Google, but like on uh, it depends a lot on how many bugs we face, to be honest. But like on average, like I've been like a GSoC student 2 times in the past, so I used to spend like somewhere around like 40 hours, 30 to 40 hours a week, and like on the weekends, like sometimes on the, so it actually varied a lot during the week based on like what tasks I used to work on. So like some weeks were like really clogged with like, oh, I'm stuck somewhere, really gotta talk to people and get through. And then some weeks were light, so you can like have a day, have like a couple of days where you're just working like 3 or 4 hours. Or if you have like your exams or stuff, it obviously makes sense that you cannot work during that time of or for preparing during the preparation period. So but just like make sure what's most convenient for you, and like make sure that you mention that in your GSoC proposal. Well, with me, I think I can say you like once the program starts, you can call me anytime. Uh, but like there also need to be some official communication hours, so which we can so like which we can like set up something like we need to have a call every Monday at this particular time, or and like have like a maybe a Scrum meeting where I can like get a IRC channel on the Scrum meeting. I can describe I worked on this. You can tell me I worked on this. This is the problem I'm facing, and then we can give you like daily pointers on, okay, let's look more into this and that, and yeah. Uh, yeah, sure. Also, so like if I think about the proposal, uh, so just like just try to work on it based on the template that I shared. So a lot of the part is also like what is not related directly to the project, but it's more about you. Because in the past, like I know like whenever we cannot predict how things are gonna go in the next 3 months, right? But like starting with a goal in mind, like this is what I can accomplish. So let's say in the first half of the program, you're like, okay, I'm going to work on level 1 configuration, and next part level 2. right? And in the first part, level one, you know that okay, we need to consolidate like a site level configuration file. Uh, so the yeah, so and make sure like we have a working configuration validation engine, and we need like some way to collect facts from the nodes which are available at the site. Facts like what, how many CPUs, what's the memory, what's like the network available, and stuff like that. And then like doing a matchmaking of let's say uh, like not doing like the complete matchmaking, but like at least having like a mechanism where we can do some sort of matchmaking, like this node looks perfect to be a worker node, this low so generally like compute elements. So like worker node is where like everything goes down, where all the processing happens. So on worker nodes it's important to have like good number of cores, so even like if you have a multi-core job, you're able to support it on the same worker node. So like some sort of we don't have to make all the decisions during the program, which we'll discover along the way as we work on the project. But we need to have some idea that we need to leave room for such adjustments to be made in that like central module, right? So first part could be working on like a level one high level specification and making sure that everything like the configuration which is expected from the containers is ready uh, for level two. And then in the second half of the program, you can focus on level two. We can like go through of how much work it is. Maybe it's very like possible that we just end up working on just like a worker node or just a compute element, or maybe both of them, depending on how fast uh, we can go through it, and like what are the challenges that we face along the way. So yeah, so like that's basically how we expect. And also like make sure you leave time for um, like documentation and testing. And like one of the goals of the program is that you as a student end up learning a lot from it as well. So like room for experimenting, or like, oh, how can I do this better, and like things like that are also like important. So like your skill development should also take place. So which is totally, so as mentors we'll do our best to also like give a good amount of focus to, okay, let's not complete this task straight away, but let's just see what new things, like how, what new things we can use to do it better already, or something like that. So like at the end of the program, you also have like a really good experience of, oh, how these different things work, not just like the worldwide LHC computing grid, but also Ansible or Docker or like networks, and all of the stuff that we'll be touching over the course of the program. Yeah. Uh, no, 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 not at all. Nope. Us. Uh, there's no limit. Like, just try to be concise and precise, I'd say. But like if you've done a lot of research, don't be shy to show it. Uh, right so like whatever you've understood so far, and uh, like how you see uh, so concise in the sense like we don't need like Wikipedia information or stuff like that. We're just looking for what you've understood, and how, what's your approach going to be. So like the more like it doesn't matter if it's like 3 pages. If you think, oh, I just need 3 pages to explain my roadmap and explain everything I plan to do, I've understood, it's enough. And if you feel like, oh, I might need more pages, like give more explanation of why and how, and like it's up to you. I would prefer like something which is more concise, precise, and original, um, just to make it clear to us like what's your stand on the project at this stage, right? And also like feel free to whenever you draft your proposal, just feel free to like throw a copy to me and Martin before you make your final submission, and we can definitely like review your proposals and like give some pointers on it, right? And he's my supervisor as well. So like so Martin kind of knows all of this thing inside out because he's been working with the grid for over 15 years, right? So he's very much aware of like what are all the conventional ways, what are these services like Cream Torque, how do they work, what do they use, what is the aim, where are the shell scripts, directories, and like everything. So Martin is very much aware of it. I am so I'm working on implementing this new concept of lightweight sites, which takes us away from all of this like old ways of like setting up sites, and you guys will be joining in and doing like a somewhat parallel implementation of it using other technologies, so that at the end of the day we can also like have some metrics. And yeah, and also like another news, so we have been accepted like a presentation at this conference called CHEP, which is like computing in high energy physics. So the work we'll be doing over the summer will also like result in a research paper at the end of it. Yeah. Okay. Hello. Yeah. Yeah. Sure. I'll try to like get a like concise document on these configuration parameters that might be helpful for you, and like put in like at least one repository which shows like the structure we're using along with the configuration parameters, how they are arranged, how they are specified, and it's currently using YAML for its level 2 configuration. So you can get some idea about uh, like it's something similar you'll be working on, but instead of YAML, it's going to be Ansible for the level 2. Okay. Okay, cool. If there are any other questions, just feel free to post on the forum or just give me an email and I'll get back to you. Yeah.